Histology. Histology is this next unit, and pretty simple. Histology, remember, ology is the study of. So histology is the study of tissues in the human body. So we're going to look at what the human body is made of, looking at 4 different tissues and how they are built, how they repair themselves, where we can find them, their functions, everything about them. So here we go. We have 4 types of tissue in the body, and obviously you know the definition for a tissue, so I won't go over that with you again. But excuse me, I have 4 types of tissue in the body. I have connective tissue, I have epithelial tissue, muscle tissue, and nervous tissue. Connective, if we're thinking of examples of like that, I have blood, I have bone, I have ligaments and tendons, I have fat or adipose tissue. Epithelial tissue, if you remember our serous membranes that lined our cavities, like the parietal pleural membrane and the visceral peritoneum, that'd be epithelial tissue. Also, if you think of the outer layer of our skin, that's epithelial tissue. Muscle tissue, you probably know there's actually 3 types of muscle tissue. There's cardiac, skeletal, and smooth muscle. Smooth muscle would be the muscle in our organs. So you don't really control that. And cardiac is in your heart, excuse me. And then skeletal would be the muscles that we control. Like, you go lift weights and you do some curls. That's skeletal muscle. Excuse me. And then the 4th type is nervous tissue. Nervous tissue would be the things that make up our brain and our spinal cord, but also the nerves of our body. Remember, we have that word conductivity, where our body can send electrochemical signals throughout our body. That's what nervous tissue is responsible for. So how do tissues develop? So this is a concept that is really an important thing to know. Basically, it deals with the reproduction and then the development of a child, right? So it starts with conception. Conception is when we have a sperm fertilizing an egg cell. And the first cell that is formed is this thing called a zygote. The first cell that every one of you and every person in the history of the world was a zygote. Now that zygote, after it forms, it goes through this rapid cell division. If you think of cell division from biology, there's 2 types. There's mitosis and meiosis. Meiosis, if you remember, forms sex cells, haploid sex cells. That's half the number of chromosomes. And then mitosis forms regular body cells. We call those somatic cells. So this zygote is going to go through rapid, tons and tons of mitosis in this process called cleavage. Okay, so we have the zygote formed. The zygote goes through cleavage, and it's just going to go through rapid cell division. Now, the cell differentiation thing, I'm going to come back to that. Basically, that's making different cells for different jobs, but we'll come back to that. Now, at the very beginning, we have these things called stem cells. Stem cells is a topic we're going to do more with in class, but it's basically a cell that's not differentiated yet, meaning it doesn't have a function. It's just a cell. Now, scientists, really smart scientists, have figured out ways to take these stem cells and then manipulate them and turn them into different tissues. Okay, so the capabilities of stem cells are really mind-blowing with the way that we're using them in therapy and regeneration of tissues and building organs. So stem cells are a really neat thing. So we're gonna, like I said, we're gonna do more with that in class. Okay, so it says the tissues appear within the first 2 months of embryonic development. So after conception, after we go through cleavage, we have this thing called the blastocyst. The blastocyst is this thing where we all start as. Okay, so I had the zygote, bunch of mitosis. Now I'm a blastocyst. This blastocyst is going to implant in the uterus, where we're going to have development. Once the blastocyst is implanted, the cells will reorganize into 3 what we call germ layers, primary germ layers. Now, this process where they turn into the 3 germ layers right here is known as gastrulation. Okay, really important term right there, gastrulation. So the blastocyst turning into these 3 germ layers is gastrulation. When we see the germ layers, that's where we start to really see the development of tissues, the different tissues of the body start to form. So we have three germ layers: the ectoderm, the mesoderm, and the endoderm. Okay, so ectoderm, you can see the things that it gives rise to. You see as it provides, makes nervous tissue, sensory organs, epidermis, hair, nails, skin glands, lines of the mouth, and anal canal. Mesoderm gives rise to muscle and bone tissue, and you can read the rest of that. Endoderm gives rise to a lot of the epithelial tissue. Now, the process of the germ layers actually forming tissues, okay? Process of the germ layers actually forming tissues is known as histogenesis. Genesis is like the creation of it. Remember, we have this histo, we're dealing with tissue, okay? So if I can repeat it one more time, I have conception where the sperm meets the egg, that creates a zygote. The zygote goes through cleavage, which is a ton of mitosis. After cleavage, I have this big ball of cells, which is basically, well, like I said, it's a big ball of cells, and that's our blastocyst. The blastocyst will then go through gastrulation to form the germ layers, and then those germ layers give rise to the different tissues. That's histogenesis. So a lot of different terms there. Okay. Now, cell differentiation is when we have different cells that have different capabilities. For example, my muscle cell has a different job than my liver cell, or my liver cell has a different job than the cells of my eyes. Okay, so histogenesis is allowing these cells to differentiate and to form new tissues. So here's what we have. Okay, I start with a zygote, go through cleavage. Notice that basically just division. This is mitosis. Now, you may see it called blastula or a blastocyst, okay? And then we start to see gastrulation, which is this right here, okay? It looks kind of weird. We're not going to go through the real biology of it and how it happens, but then we get to these three primary germ layers. There's some things on here you don't necessarily need to know right now, but that is where we're forming the germ layers, and this is where our tissues will come from. And this is a really important key. We can look at the germ layers of other mammals and things that are related to us and see that they go through these same stages, which is a piece of evidence that scientists use to say, hey, we have evolved from a common ancestor because we go through these common stages of development. So what do we develop into? Just a diagram of what I'm sorry, I keep moving my photo around for you. Basically the different layers and what they develop into. This is just kind of a brief explanation of it. But I do want to point out, when we have after gastrulation, the endoderm is on the inside of that ball of cells after gastrulation. The mesoderm is the middle layer, and the ectoderm is the external layer. And that is all.